See, this is the program for finding factorial of an input number using recursion. Now, first of all, what is a recursion? See, recursion is a concept where you call a function from within its own body. That is, the function itself calls it within its body. So it will be an endless program, right? So in every recursive function, there has to be one exit condition. And if that exit condition is not supplied, it will go into an infinite loop. We'll see how. Like for example, in this program of finding factorial of an input number, we will start from the main function. You are asking the user to enter a number whose factorial is required. Suppose user enters 5. You are assigning that value 5 after converting into integer to the variable n. Here in the print statement you are displaying the factorial of n. We are assuming that the user has entered 5 is, you are invoking fact function and you are taking n, the value of n as an argument. That 5 will be assigned to x parameter. Now here this is the exit condition. You are asking if the value of x is 1, go back to the main function taking this value 1. Okay. But the value of x is 5. So control will go into else. Here what you are doing, you are asking the compiler to go back to the main function taking the value of x, that is 5. But here is a recursive function call. You are in fact function and you are calling fact itself, and with the value what? With the value 5 minus 1, that is 4. You are asking the compiler to call fact function with value 4. But what about this? This line, this 5 was supposed to go back to the main function. So the statement which are unable to run because of recursive call, compiler stores them into a stack. Now this is the stack. Stack is a LIFO structure, last in first out. Whatever you insert at the last will be taken out first. It is a sort of a bucket. See, the process of putting into the stack is known as push. The process of taking out from the stack is known as pop. So if you push a statement, it goes at the bottom of the stack. When you push another statement, it will stay at the top of the last statement which was pushed. Got it? So all the statements will be kept one after the other. And when you start popping, the last statement which was pushed into the stack will be the first statement to be popped off. Okay. So this 5 which was supposed to be taken to the main function is pushed into the stack. Now this fact function is called, this 4 is assigned to the parameter x. Is the value of x equal to 1? No. Control will come over here. Return to the main function taking 4 and call the fact function with value 3. 4 minus 1 is 3. So this 4 cannot be taken to the main function. It will be again pushed to the stack. When the recursive function will gets over, compiler will take out every value from the stack and will apply the multiply operation onto all statements. Because all values in the stack have to be multiplied with the value returned by the next recursive function call. Got it? So 4 is also pushed to the stack. Now fact function is called with the value 3. 3 assigned to the parameter x. Is 3 equal to 1? No. Return to the main function taking value 3 and call the fact function with value 2. Because the recursive function is again called, this 3 is pushed to the stack. This 3 will be again assigned to the parameter x. Is 3 equal to 1? No. Go to the main function taking the value 3 and call the function fact with value 2. So 3 is pushed to the stack. This 2 is assigned to the parameter x. Is value 2 equal to 1? No. Go to the main function taking the value 2 and call the fact function with value 1. Because of this function called fact1, this 2 cannot be taken back to the main function. So 2 is also pushed to the stack. Fact function is called with the value 1. That value 1 is assigned to the parameter x. Is x equal to 1? Yes. So you go back to the main function taking the value 1. So compiler will take 1 and will go back to the main function, but it will first watch the stack and it will first pop out all the values in the stack and will multiply with the value 1, and the final result will be taken to the main function. Got it? So 1 will be multiplied with the first value in the stack. As I told you, it's a LIFO structure, last in first out. The last value is 2. So 1 will be multiplied by 2. The result is 2. Then the next value is popped, that is 3. 2 into 3, 6. Then 4. 6 into 4, 24. Then the last value is popped out 5. 24 into 5, 120. And that 120 will be displayed here, will be substituted here. So the result is the factorial of 5 is 120. Let us run this program. I am copying it. Pasting into spat ID, running it. It's asking me enter the value whose factorial is required. Suppose I enter 5. Factorial of 5 is 120. I run it again. What is factorial of 10? 10 into 9 into 8 into 7 up till 1. The multiplication of all the values from 1 to 10 is nothing but the factorial of 10. So if I want the factorial of 3, it is the multiplication of 3 into 2 into 1. That is how much? 6. If I run it again, enter the number whose factorial is required, I enter 10. See, 362880 is the factorial of value